Scatterplots are a type of graph that displays the relationship between two sets of data. They are commonly used to identify patterns and relationships between variables. The position of each point in this scatterplot tells us what the ice cream sales were for various high temperatures for the day. The pattern shows that ice cream sales tend to increase when the temperature increases. Now, each point on the scatter plot matches up with a row in this table. So, for instance, on a day that had a high of 14.2 degrees Celsius, the ice cream sales were $215, and that matches up with this point here. So there's two numbers make 1 point. To make a scatter plot with this data, well, we have hours studied on the x-axis and the test score on the y-axis. So for the first student who studied 1 hour and received a score of 9, we would just go up from 1 hour to a test score of 9 and put a point. So 1 point for two numbers. 2 hours studied, score of 7. 5 hours studied, score of 19. 6 hours studied, score of 17. 8 hours studied, score of 16. Now we don't have very much data here, but we can see somewhat of a pattern from even these limited 5 points. So sometimes the points in a scatter plot show a pattern. They might tend to form a straight line or a curving pattern. Other times they do not, like these points are just scattered about. One way we can describe any patterns we see is with their association. In this first scatter plot, the points are generally in a line, and they're going up from left to right. So this is a positive linear association. In the second scatter plot, the points are also more or less in a line, but they're going down from left to right. So this is a negative linear association. This scatter plot here does show a pattern, but the points are not lined up in any kind of linear pattern. So we call this a nonlinear association. They do show a pattern, but it's not linear. And here in this last scatter plot, these points don't make any pattern at all. So we're going to say this shows no association. So association is all about what kind of pattern we see if there is one. Now, correlation helps us with linear relationships. So it's very similar to what we just talked about with association, but we only use correlation when we see a linear association. So correlation measures how strong a linear relationship is and what the direction is. So this first one, the points are going down from left to right. The points are huddled pretty close to a linear pattern here, and they're going down from left to right. So this has a strong negative correlation. This scatterplot also has points that show a linear pattern that goes down from left to right, but these points are not huddled so close to where that line would be. So this is more of a weak negative correlation. These points don't show a linear pattern at all, so we can say no correlation. Now, once again here, we have a somewhat weak linear pattern that we see. And the points are generally slipping up from left to right. So this is a weak positive correlation. But these points form a nice linear pattern going up from left to right. So This is a positive correlation and is fairly strong. These points are huddled together fairly closely. So we use correlation to help us describe linear relationships. Now we can take this further by actually putting a number to this correlation. And to do that, we use the correlation coefficient R. So the correlation coefficient R measures the direction and strength of a linear relationship. Calculating R is pretty complex, so we usually rely on technology for the computations, but here are some facts about R. It always has a value between -1 and +1. Strong positive linear relationships have values of R closer to +1. Strong negative linear relationships have values of R closer to -1. So notice both 1 and -1 represent strong correlations. One is for positive correlations and the other is for negative. Now, weaker relationships have values of R closer to 0. All right, so let's estimate the correlation coefficient R for these scatterplots. Now here, to our naked eye, we don't see any linear relationship to speak of. So if we actually calculated R, we would probably get something like R equals -0.04. So we might not get exactly 0, but we would get a number very close to 0 when our eyes don't see any sort of linear relationship. Now here, these points roughly trend down from left to right, and they kind of make a line, but not a very good one. So this will have a negative correlation. It's going down from left to right, but it will be closer to 0 than to -1. So this might have a correlation coefficient R of, say, -0.4. Here we have a positive correlation. The points are sloping up from left to right. Once again, the points are fairly spread out, so this is not going to be a strong correlation. We might end up with an R of something like +0.5. Okay, these points are a little bit closer to where a actual line would be. They're sloping down from left to right. So it will have a negative correlation, maybe a little bit closer to -1 than to 0, so something like -0.6. Here where the pattern is getting closer and closer to an actual line. These are sloping up from left to right, so this might have a correlation of +0.7. And here we finally have a strong correlation. These points are very close to where a line would be. It's negative, they're going down from left to right, so this might have a correlation of something like -0.9. Pretty close to -1. Now when we have a data point that does not fit the pattern in a scatter plot, we call that point an outlier. So let's just draw an outlier on the scatter plot. So these points are all roughly following this linear pattern, but if we put a point over here, that point doesn't fit this pattern at all. So this point is an outlier. Now, the line of best fit can be an educated guess about where a linear equation might fall in a set of data plotted on a scatter plot. So we can actually draw a line through these points that fits the overall pattern nicely. So let's sketch a line of best fit on this scatter plot. So here I just did the best I could to put a line through more or less the middle of the pattern. And this is my line of best fit. Notice about half the points are below that line and about half are above it. It goes through a few points, but that's just by coincidence. You don't have to go through the first point or the last point or anything like that. All right, so in this video, we learned how to make and analyze scatter plots. I hope these examples have been helpful. This is Mr. Ela signing off.